Hello everyone, welcome back to our channel. In today's video, we will be discussing about our new lesson, and that would be graphing exponential functions. So I hope that you're going to enjoy this lesson. So let's get started. Hello everyone, this time we're going to have our new topic entitled graphing exponential functions. Since we are done discussing about we're done discussing about solving exponential equations. Now this time we will now graph exponential functions. Okay, so let's start with the objectives. For graphing exponential functions, we have here the objectives. Number 1, graph exponential growth functions. Number 2, graph exponential decay functions. Okay, so we have here exponential function. Let's try to recall the definition of exponential function. We have a function of the form f of x is equal to b to the power of x, where b is greater than 0 and b is less than 1, or b is greater than 1, is an exponential function wherein the variable is the exponent. So you have here the word asymptote. So what do you mean by asymptote? Asymptote, the graph of an exponential function has an asymptote, which is a line that the graph of the function approaches but does not cross or touch. Okay? So it will just approach that particular line, but it will never ever intersect. Okay, so let's have an example. Exponential growth function. So an exponential growth function is a function of the form f of x is equal to b to the power of x, wherein b is greater than 1. So this is the definition of exponential growth. We have here the parent function. We have f of x is equal to b to the power of x, wherein b is greater than 1. The asymptote would be x-axis, or y is equal to 0. And the y-intercept here would be 0, 1. Okay, let's continue. Now let's have an example. If we are asked to graph y is equal to 3 to the power of x. Now, you've noticed we have here the table of values with 2 columns. This is for your x values, this is for the y values, and we have this the graph. So, for us to solve, or for graph y is equal to 3 to the power of x, for us to graph this exponential function, we need to complete the table. Remember before, you know already how to evaluate functions, wherein every time you encounter the variable x or a variable x, you need to substitute the value, whatever the value of your x here, then that will give you your y value. So you can plot the points later on. So we need to complete this table of values. So by completing the table, we have to substitute negative 3 for x. Okay, let's start completing this table. If x is equal to negative 3, what is the value of y? So y is equal to 3 to the power of negative 3. Remember, our exponential function is y is equal to 3 to the power of x. So therefore, you have y is equal to 1 over 27. Remember, if our exponent is negative, we can only solve it when we are going to place it into, make it into positive by making, okay, for a moment. So we have here, so that means that if 3 to the power of negative 3, that is equivalent to 1 over 3 cube. Okay, 1 over 3 cube. And 1 over 3 cube is the same, equivalent to 1 over 27. And 1 divided by 27 is 0.04. or 400ths. Okay, just limit your decimal point here, in this case, to hundredths place. So we have now the answer. We have to write 0.04 in the table. Now let's proceed to the next. Substitute -2 for x. So if our x is -2, what is the value of our y? So go back to our exponential function. Y is equal to 3 to the power of x. Our y is equal to 3. Our x is -2. Remember, the 3 to the power of -2 is the same as 1 over 3 squared. Okay, 3 squared is 9. Therefore, y is equal to 1 over 9, or 1 divided by 9 is 0.1. So we're going to write that here. So write 0.1 in the table. Okay, next, let's continue. Continue substituting numbers for x until the table is complete. So if if x is -1, what is our y? The value of our y would be 0.3. Okay. The same procedure, just solve it. If our x is 0, what is y? So that would be y is equal to 3 to the power of 0. So y to the power of 0, any number, any variable, or any expression raised to the power of 0 is always equal to 1. So this would be 1. Okay, next. Y is equal to 3 to the power of x. If our x is 1, so our value would be, the value of our y would be 3, because that is 3 to the power of 1. So you have 3. Now, if our x is 2, y is equal to 3 squared. So 3 squared is equivalent to 9. Okay. Now, the table of values is now complete. So you have your x values and you have your y values. Now, this time we are ready to plot the points. So plotting the points, we have, okay, this is our -3.04, -3, then 0.04 as our y, then -2, 0.01, 0.1, then we have -1, we have 0.3, then 0.1, this is the point for 0.1. The next is 1.3. You have 1.3. Always remember, you have to look at the x values first in plotting the points, then y, followed by the y coordinate. Then lastly, we have 2.9. Okay? After plotting the points, we are going to connect the points, and now we have this graph. Now plot the points on the graph and connect the points with a smooth curve with arrows at both ends. Always remember to place arrows on both ends, like this one. And do not cross the x-axis. Why you should not cross the x-axis? Because it is asymptotic to the x-axis, wherein y is equal to 0. Remember, okay. Remember, if this is how the function looks like, the asymptote would be x-axis, or you're going to write it y is equal to 0. Meaning, it is the line wherein the graph will never intersect, but it only approaches to that specific line. So this is, the asymptote is x-axis, or y is equal to 0. So I hope everything is clear so far. Now let us proceed to another example. If you are asked to graph y is equal to 4 to the power of x, if you have here x column and this is your y column, you have x to the we need to complete the table for us to plot the points, okay, for us to graph this exponential function. So the same procedure, okay, so you are going to use the same procedure as the previous example, okay, but remember, you have to show your solution. if y is equal to 4 to the power of x, if x is negative 3, okay, let's try to solve just an example, so you will be guided as to what to do. So this is our exponential function. Now if x is equal to negative 3, okay, if x is negative 3, you have here 4 to the power of negative 3. And 4 to the power of negative 3 is the same or equal to 1 over 12. So 1 over 12, 1 divided by 12 is 0.02. Okay, again, you just simply express your answer in hundredths place or at least 2 decimal places. Okay, same is true with this one. If x is negative 2, our value of y is 0.06 or 6 hundredths. If x is negative 1, our value of y is 0.25. If x is 0, our y is 1. If x is 1, our y is 4. If x is 2, our value of y is 16. Okay, now transformations. The graph of f of x is equal to b to the power of x represents a parent graph of the exponential functions. The same techniques used to transform the graphs of other functions we have studied can be applied to the graphs of exponential functions. Now, if you have here f of x is equal to ab to the power of x minus h plus k. So what if we do have or will encounter an exponential function like this one? Okay? So always remember that h is our horizontal translation and h is the units left if h is positive. The absolute value of h, the units right if h is negative. Then k is vertical translation and k units up if k is positive, and absolute value of k units down if k is negative. And k is also the horizontal asymptote. So you have to familiarize this one so you can actually picture out what does the graph look like if you're only given the exponential function. Okay, now let's continue. So for f of x is equal to ab to the power of x minus h plus k, a would be the orientation and shape. If a is less than 0, the graph is reflected in the x-axis. If absolute a is greater than 1, the graph is stretched vertically. If the absolute value of a is greater than 0 but less than 1, the graph is compressed vertically. Okay, let's have an example. Graph each function y is equal to 2 to the power of x plus 1. So we have here the table of values. Okay, so we have the table of values. These are x values and y values. So the same procedure, all we have to do is substitute the value of x so we can solve the value of y. So if x is negative 3, our y is what? Okay, complete the table, substitute negative 3 for x. So y is equal to 2 to the power of negative 3, then plus 1. 2 to the power of negative 3, that is 1 over 8. Then plus 1, then y is equal to 1.125. Or just write 1.1 in the table. So you have that. Let's continue. Substitute negative 2 for x. Y is equal to 2 to the power of negative 2 plus 1. So 2 to the power of negative 2 is the same as 1 over 2 squared. So that is 1/4. 1/4 Fourth is 0.25. Then plus 1, that's 1.25. Okay, so you have it here. Write 1.25 in the table. Next, continue substituting numbers for x until the table is complete. Then graph the points and draw the graph. So we have here if x is negative 1, our y is 1.5. If x is 0, our value of y is 2. If x is 1, our value of y is 3. If x is 2, our value of y is 5. If x is 3, our value of y is 9. Actually, it's very easy for you to solve these values the moment you substitute the value of x in your exponential function. Okay? So, let's graph. Okay, so the graph would be, let's start if this negative 3, 1.1, so that is here. Okay. Then negative 2, 1.25, so that's here. Next point is negative 1, 1.5. Then 0, 2. Next is 1, 3. Okay, take a look at the coordinates 1, 3. So look at the x-axis 1, then look at 3 here. That's in between 2 and 4. The next would be 2, 5. So this your x value is 2 and the value of your y is 5. So that here, that point. Next is 3, 9. The value of your x is 3, then the value of your y is 9. Then we are going to connect all the points and draw a smooth curve, and we are going to place arrows on both ends. Okay. This graph has a horizontal asymptote at y is equal to 1. Again, as you can see here, this is the asymptote. This is the line of asymptote. You have here y is equal to 1. Remember, this tells us the asymptote. Okay? Because of the plus 1 after the 2 to the power of x. This is our k, or our asymptote. So, draw a dashed line at 1. Okay, so you need to draw that 1. Then the graph cannot cross or touch this line. Since it is only asymptotic to line y is equal to 1, this will never ever intersect y is equal to 1. It will just be an asymptotic to this line, meaning it will just approach but never intersect. The graph will just approach but will never intersect. Okay, I hope everything is clear so far. Okay, let's proceed to the next. Okay, graph its function. How about if we are dealing with fractions this time? Okay, what about this one? So y is equal to negative 1/2 times 5 to the power of x minus 2. So these are our values of our x, given values, and this is your y. We need to complete the table so we can graph the exponential function. Okay, so let's start. Complete the table, substitute negative 1, the first value of our s, negative 1 for x. Okay, so that becomes y is equal to negative 1/2 times 5 to the power of negative 1 minus 2. That gives us 0.004, or remember, 5 to the negative 1 minus 2, that's 5 to the negative 3. Then it becomes, okay, so you can, okay, let's try. So this becomes negative 1/2. So this becomes negative 1/2 times 5 to the power of negative 3. That is negative 1 minus 2 is negative 3. Okay, then is equal to negative 1/2 Okay, negative 1/2. 5 to the power of negative 3 is the same as 1 over 5 cubed. Okay, so it's equal to, what is 5 cubed? 5 times 5 times 5, that is 125. So you have negative 1/2. Okay, times 1 over 125. So just simply multiply both numerators, multiply both denominators. Okay, after multiplying both numerators and both denominators, so you will have, okay, so negative 1 times 1, that is negative 1. Then 2 times 125, you have 300. Oh no, 250. Okay, 250. Okay, so you can check on your calculator what will be the answer. So that would be 1 divided by 250. That gives you negative 1 divided by 250. That gives you negative 0.004. Okay, a while ago I told you that you just simply write the hundreds place, but in this case it's 0.00. You will end up this 1 if this is hundreds place, so you need to complete the answer, because remember, we cannot have y is equal to 0, because it's either asymptotic to the x-axis or the value of y. So it will never cross the x-axis. It will never touch the x-axis. So if we are going to write it's 0.00, then that is just meaning it touches the x-axis. So you have here no, I mean, if this is negative 1, and that is for the case if x is 0. If we're going to have 0.00 here. But in this case, this you have to write negative 0.004. So you have negative 1, negative 0.004. So that is the first ordered pair. Okay, proceed. So we will not going to solve it one by one, since I have presented to you the solutions on the first value of y if x is negative 1. Just continue the procedure and follow the process on how you're going to solve for y after substituting the value of x. So continue substituting numbers for x until the table is complete. Then graph the points and draw the graph. So this is now the value. If x is 0, y is negative 0.02. If x is 1, you have negative 0.1. If x is 2, that's negative 0.5. If x is 3, that's negative 2.5. If x is 4, negative 12.5 is the value of y. After which, we are going to substitute the values. Okay. Let's start. If x is negative 1, y is negative 0.04. So it is here. If x is negative 1, our y is negative 0.04. Then if x is 0, y is negative 0.02. Remember, it looks like it is in the origin. Okay, because the dot is quite bigger. However, you have to look at properly the graph. It's not at the origin because it's not 0, 0. Always remember that the ordered pair at the origin is 0, 0. It's not 0, 0, so it's not at the origin. It's just very close to the origin. Then next, if x is 1, y is negative 0.1. So that's here. Then if x is 2, here, if x is 2, y is negative 0.5. Okay, y is negative. So if x is 2, this one, y is negative 0.5. If x is 3, this is 3, between 2 and 3. If x is 3, y is negative 2.5. Negative 2.5 is in between, because there's 3 here. Okay, so that's why in between, this is the negative 2.5. So if x is equal to 4, y is negative 12.5. So that's here. Okay. After plotting all the points, we need to connect the points and draw a smooth curve. Remember, it should not touch the x-axis. Okay. And then we need to place arrows on both sides. So this graph is reflected because 1/2 is negative. Here, remember the value of a on our exponential function. If a is negative, then the graph does not cross or touch the x-axis, and it is reflected, meaning the orientation is like this because it's negative. And it is the asymptote would be x-axis because there's no constant here, like there's no value of k here after this expression, okay, or term. Okay, let's continue. Now let's have a practice. Graph each function. Y is equal to 2 to the power of x plus 3 minus 5. Okay. The same procedure, we need to solve the value of y if our x is negative 5. So if x is negative 5, our y would be, okay, so you have already the answer here. You have 2 to the power of x plus 3 minus 5. If x is equal to negative 5, just simply substitute the value here, negative 5, then plus 3 minus 5. You solve it, you will get negative 4.75. If x is equal to negative 4, so you have here, y would be, just substitute the value of x, which is negative 4. Then you have y is equal to 2 to the power of negative 4 plus 3 minus 5. You will get negative 4.5. If x is negative 3, substitute negative 3 here. Okay. Then, after that, you have 2 to the power of negative 3 plus 3 minus 5. Then that becomes, the answer would be negative 4. Because negative 3 plus 3 is 0. 2 to the power of 0 is 1. 1 minus 5 is negative 4. Now, if x is negative 2, that is 2 to the power of negative 2 plus 3. So that is 2 to the power of 1. That is 2 minus 5. So you have negative 3. Now, if x is negative 1, that is 2 to the power of negative 1 plus 3. That becomes 2 to the power of 2, or 2 squared. 2 squared is 4. 4 minus 5 is negative 1. Now, if x is 0, so that becomes 2 to the power of 0 plus 3. That becomes 2 cubed. 2 cubes is 8. 8 minus 5 is 3. Now, if x is equal to 1, that becomes 2 to the power of 1 plus 3. 1 plus 3 is 4. So that is 2 to the power of 4. 2 to the power of 4 is 16. 16 minus 5, that gives you 11. Then, after that, you are going to graph, plot all the points. For x is if x is negative 5, y is negative 4.75. Then, if x is negative 4, y is negative 4.5. If x is negative 3, your y is negative 4. If x is negative 2, y is negative 3. Then if x is negative 1, y is negative 1. So we have it here. If x is 0, y is positive 3. So this is 1. If x is 0, y is positive 3. If x is 1, then y is 11. X is 1, then y is 11. Then afterwards, we are going to look at this one. The value of our k is negative 5. So, it means to say that there is a horizontal asymptote at y is equal to negative 5. So, this is the dashed line on the graph. So, you are going to create a dashed line on the graph. Meaning, this graph is asymptotic to this line. Y is equal to negative 5. Okay. Let us proceed to number 3. So, we have an exponential function. Y is equal to 0.1 times 6 to the power of x minus 3. So, we have the values x, first column, and the value y, second column. So, the given values of x, we have negative 2, negative 1, 0, 1, 2, and 3. So, we are going to solve as the same way as the previous problems or previous examples. So, substitute the value of our x here. If x is negative 2, that is y is equal to 0.1 times 6 to the power of negative 2, then minus 3. The resulting value is negative 3. So, if x is negative 1, substitute the value here, negative 1, then solve for y. The resulting value would be negative 2.98. If x is 0, then that is y is equal to 0.1 times 6 to the power of 0 minus 3. The answer would be negative 2.9 as our value of y. If x is 2, you have negative 1, negative 0.1 times 6 to the power of 2. Where are we now? Meaning if our value of our x is 1, so y is equal to 0.1 times 6 to the power of 1 minus 3. The answer will be negative 2.4. If x is 2, that is 0.1 times 6 to the power of 2 minus 3. The answer of y would be 0.6. If our x is positive 3, that would be 0.1 times 6 to the power of 3, then minus 3, the answer would be 18.6. So after which, we are going to graph, plot the points. So negative 2, negative 3. Negative 2 of our x, and here negative 3 of our y. Next, negative 1, negative 2.98 here. Then 0, then negative 2.9. That is close to negative 3. Then next, if x is 1, positive 1, y is negative 2.4. That's here. Then if x is 2, y is 0.6, positive 0.6. If x is 3, here, y is 18.6. Okay. After plotting the points, we are going to connect the dots and then draw a smooth curve and then place arrows on both ends of this graph, and then we're going to draw a dashed line on the graph, which means this is our horizontal asymptote. So take a look at the exponential function. There's negative 3 after this term with exponent x. So this is our guide. This would be our horizontal asymptote. So there is a horizontal asymptote at y is equal to negative 3. So this is the dashed line on the graph, meaning this graph will just approach this line but will never intersect. Okay, let's proceed. So how about exponential decay function? An exponential decay function is a function of the form f of x is equal to b to the power of x, wherein b is greater than 0 and less than 1. Meaning the value of our b will be less than or in between 0 and 1. So the parent function would be f of x is equal to b to the power of x, wherein b is greater than 0 and b is less than 1. So the asymptote of this expression would be x-axis, and the y-intercept would be 0, 1. Okay. So let's continue. So example, graph each function y is equal to 1/3 to the power of x. So this is an example of an exponential decay function because the value of b here is greater than 0 but less than 1. Remember, 1/3 is equivalent to 0.3. Okay, that's actually a repeating but non-terminating decimal number. Okay. So if x is negative 2, what would be the value of y? So we have here, complete the table, substitute negative 2 for x. So we will have y is equal to the quantity of 1/3 raised to the power of negative 2. Remember, this is the same as 3 squared. To make the exponent positive, the 3 here will be on the numerator, then it becomes positive. So that is 3 squared. So y is equal to 9. That's why we have here 9. Continue substituting numbers for x until the table is complete, then graph the points and draw the graph. So in this case, if x is negative 1, what would be the value of y? So the value of y would be positive 3. If x is 0, the value of y would be 1. Remember, any number raised to the power of 0 is 1. If x is 1, the value of y would be 1/3 or 0.3. If x is 2, the value of y will be 0.1 because that becomes 1 over 3 squared. 3 squared is 9. 1 over 9 is 0.1. Okay. After that, we are going to plot the points. Let's start for negative 2. Here is negative 2 and this is 9. Then negative 1 for our x, and then positive 3. Then 0, then positive 1. Then 1, then 0.3. Then 2, 0.1. Okay. Then, okay. There's actually no more 3 here, but in case we have 3, the value would still be greater than 0. It will not intersect the x-axis. So this is now the points, and then we're going to connect the points and draw a smooth curve and put arrowheads both ends. So the asymptote is x-axis in this exponential function. Okay, because there's no constant or there's no term after this term. There's no other constant values or the h values after this term. Okay, next. Graph each function. B is equal to y is equal to b. For letter B, y is equal to 2 times the quantity of 1/4 raised to the power of x plus 2 minus 3. So the same process, we have to complete the table of values. Let's start. If x is negative 3, what is the value of y? So complete the table and sketch the graph. So if x is negative 3, what is the value of y? So if this is negative 3, you have to be very careful with your signs. If this is negative 3, then plus 2. Okay, let's have an example first for this one. Just one example. So y would be equal to 2 times 1/4. Okay, 1/4. X would be negative 3 because x is negative 3. Then plus 2. Then minus 3. Okay, so this will be equal to, we have here 2. That becomes 1/4 to the power of negative 1 minus 3. Okay, to make the exponent positive here, we need to get the reciprocal. So it becomes 2 times 4. Okay, we can write or we don't need to write. That's okay. That's the exponent is already positive 1 minus 3. Then we have 2 times 4 is 8. That becomes, that's 8 minus 3. 8 minus 3 is equal to, okay, 5. So that's why our value of y is 5. So the same procedure, you are going to use the same process. Just be careful with the signs. Then you are going to solve for y. So again, if x is negative 3, our y is 5. If x is negative 2, our y is negative 1. If x is negative 1, our y is negative 2.5. If x is 0, our y is negative 2.9. And if x is 1, our y is negative 2.97. So after completing the table, we are now ready to plot the points on the graph. Okay, let's start. So if x is negative 3, we have here negative 3, the value of y is 5. Here is x, negative 3, the value of y is 5. This is the point. If x is positive 2, the value of y is negative 1. We have this point. If y is negative 1, this is, x is negative 1, the value of y is negative 2.5. Then if x is 0, the value of y is negative 2.9. If x is positive 1, the value of y is negative 2.97. Okay, and the horizontal asymptote would be this value. Always remember that one, negative 3. Okay, so we are going to use a dash, we're going to make a dash line here, meaning this is our horizontal asymptote. It is where the graph approaches but will never intersect. Okay, so this graph has a horizontal asymptote at y is equal to negative 3. Okay, that's it, at y negative 3. Okay, so I hope that you are able to understand on how to graph an exponential function and how to get the asymptote, the horizontal asymptote based on the given function. Okay. Now this time you need to graph each function. This is for your assessment, number 4 and number 5. So you have to answer for number 4, you have y is equal to negative 3 times the quantity of 2 over 5 being raised to the power of x minus 4 plus 2. Solve first the table of values. You have to complete this one. Our x is 2, 3, 4, 5, 6, 7. Complete the y values, but make sure that you are going to show your solution in solving for y. I will be giving points for the solution in solving for y in each block. Okay? So the same is true with number 5. Number 5 is y is equal to 3 over 8 times the quantity of 5 over 6 being raised to the power of x minus 1 plus 1. The x values are negative 16, negative 12, negative 8, negative 4, 0, 4, 8, then 12. The y values are unknown. You have to complete the table, then plot the points, sketch the graph, and make sure to show the horizontal asymptote. The same is true with number 4. Show the horizontal asymptote. Okay, so you are going to write your answer on your math activity notebook. Make sure that you're going to follow this graph, or you can use a graphing paper and attach it to your mathematics activity notebook, so there will be a precision on your graph. Okay, so to end this video, let's have a math code. So math is the only place where truth and beauty mean the same thing. So that would be all for this video lesson. Thank you so much for watching, and please don't forget to like, comment, and subscribe my channel. Bye!